Tēnā koutou katoa. Pleasure to welcome you today to today's session, and we're very fortunate to have three representatives from Taranaki Regional Council with us. Scientists Fern Kumeroa and Romy, as well as the Land Services Manager Don Shearman. So they will give us an overview today about what they know about the sediment on the Waitotara catchment, its current state through the monitoring that TRC is conducting, but also talking to us about future modelling, as well as obviously TRC's land management program. So without further ado, I'll just hand it over to you, Fern. Thanks so much for being here.
Thank you. Tēnā koutou katoa, ko Fern Kumeroa. So as Lisa said, I'm a scientist for TRC. So me and Romy will be speaking to the monitoring and modelling that we do within our teams, and then we will pass it on to Don, who will talk about the sustainable land management in the Waitotara catchment. So just a bit of the background as to what we know about the Waitotara catchment. It is the largest catchment in our region. It's about 116 kilometres squared, and it makes up what is proposed to be our Southern Hill Country Freshwater Management Unit. And these FMUs are important because they are a way for us to organise and guide our freshwater management and make sure our planning reflects our local landscapes, pressures and community values. So the Southern Hill Country FMU is made up of 4 catchments, Waitotara and Wenuakura in the east and the Tangahoe and Manuapo in the west. And it's split up by the Pātea, which has decided to be in its own FMU, but those 4 catchments are primarily part of that FMU because they begin as fast-flowing, narrow streams, and they start from steep and hilly terrain, and as they move downstream and the topography flattens out, they become a lot more wider and a lot more long and slow-moving. And these are different from our other rivers that flow from, say, Taranaki Maunga, so the area that's on the map in the area that's on the east side along the coast. A lot of those rivers are a lot more flatter and straight and fast flowing because the landscape's a lot more uniform. And so one thing with the Southern Hill Country FMUs, especially the Waitotara catchment, is because of the landscape, it's so erosion prone, and it means that sediment is a key pressure in the Waitotara catchment. So it's important to make sure we're monitoring a whole range of locations across it. So this map here is just a visual guide to the monitoring that we do in the Waitotara catchment currently. So we have our discrete monitoring sites, which are the smaller circles on the map, and they are sites where we take a sample or measurement at a specific point in time. And then we've got our continuous monitoring sites, which are the bigger, larger circles, and they give us the real-time environmental data, so your rainfall and your flow and your sediment, your soil conditions, and that helps us track how our catchment is responding to weather, to land use, and to any sort of seasonal changes. So while it does look like we have a few sites scattered along the catchment, I did just want to point out that outside of the Waitotara, we do monitor other things in other catchments, such as water quality, groundwater, periphyton, fish. So programs that we do have established, but we haven't quite made it to establishing sites in the Waitotara as of yet. But for the rest of the speaking time, I'll be focusing on some of this discrete monitoring that we carry out for macroinvertebrates, lakes and estuaries, as those are the programs that my team spends a lot of time monitoring and managing. And so we do that because it helps us assess those long-term ecological health and track how the environment's changing over time, and especially in the Waitotara catchment, how sediment might play a major role in the health of those ecosystems. So I'm the project lead for the macroinvertebrate program, and we also have scientists for our lakes and estuaries, and they have helped provide me with some notes to talk about this. So just to sort of give thanks to everybody in my team as well. So starting with macroinvertebrates, we have 2 sites that have been added within the last 5 years to the Waitotara catchment, and this is in the Momahaki and Waiau streams. And in the sense of the macroinvertebrate program, this isn't a very long time. The macroinvertebrate program's almost 30 years old, so having sites with less than 5 years of data is a small time frame. But we added these specifically to assess, help build a bigger picture on the sort of more eastern sides. We have a lot of sites around the ring plain, and we're slowly establishing more sites outside of that. So the macroinvertebrates are assessed for 3 metrics: the MCI, ASPM, and SQMCI. And I think it's important to note that these are metrics originally developed for nutrient enrichment and pollution, which I'll cover that in a little bit. So the MCI and ASPM focus on the presence and absence of sensitive taxa, and these are quite often correlated, so the scores are usually somewhat the same. And then the SQMCI focuses on the relative abundance. So looking at the table on the slide, we can see that for both sites, MCI and ASPM are both sitting in D band, while SQMCI is sitting in C band. And that's suggesting that while some moderately sensitive species are present, that the communities are largely dominated by tolerant taxa. And this could be because of the slower flows in the region and sediment being an unfavourable habitat. Unfortunately, we don't have the water quality or sediment data yet to sort of confirm that, but that's sort of where we're thinking might be the case. And which goes on to say it is really important to consider that habitat context. So these sites are naturally soft-bottomed and slow-flowing, which means they don't often support the species to have to result in higher bands, like A or B band. And that's just largely because, as I said earlier, the metrics are designed for nutrient enrichment and pollution. So that's just sort of something to be really considerate of when looking at these results. Alternative habitat monitoring does exist for soft bottom streams, but TRC hasn't yet officially classified these sites as soft bottom. So while the metrics do exist, we currently don't have that data. And it's definitely something we're looking at in the future, just to make the results a bit more accurate to the sites. Yeah, but in saying that, the sediment is showing to have an effect on these communities, and sediment is known to affect macroinvertebrates. And when we get sites with high sediment or are more prone to high flows and more turbidity, it does still cause degradation if it's not monitored. And again, in saying that, when talking about the metrics, because they are newer sites, they are calculated using incomplete data, so it's not as robust as we would like the data to be, which sort of just emphasizes that more monitoring is needed, and we will continue monitoring these sites over time. But yeah, more just giving a bit of context, because yeah, the sites are currently in D and C band, but that doesn't mean it's a red flag just yet. It doesn't mean that they're bad sites. There's just a lot more context that we need to have provided to understand them. So moving on to lakes, we've had a few cool projects happening in our region over the lakes for past little while. So Lake Waikato, we monitor monthly for water quality and cyanobacteria under our state of environment monitoring program. It's a reasonably deep lake. It's about 19 meters, and it's surrounded by sandstone, which means it's pretty prone to erosion, and we're seeing a lot of sediment getting into that lake from the catchment. So TRC has recently commissioned Cawthron to estimate reference conditions of the lakes in our region, and as part of that, they drilled sediment cores in a bunch of lakes, and they did this to explore sort of the historical changes and to help establish reference conditions before human arrival. So the core at Lake Waikato didn't quite capture that. It only captured about 200 years of history. And from the results, they're assuming that the lake probably didn't exist before humans arrived in the area. The core itself didn't reach pre-human sediment layers because there was so much sediment has been so much sediment going into the lake. So we currently don't have an exact reference condition to work from, but what the results showed was that the soils are really fragile, and the vegetation really needs to be managed to help stabilize the area surrounding the catchment. The lake itself is in a forestry zone, so that sort of thing is a lot more important there. Lake Momahaki was a similar case, so it's a little bit deeper than Lake Waikari, but it has the same sort of geology, so it has the same erosion problems and same management problems. Cawthorne did manage to drill a longer core than that, but it only captured the period after Māori settlement to the region. So again, no pre-human baseline, but the key message was the same, was that there's a lot of erosion, a lot of sediment, and we need good management plans. And in addition to the Cawthorne report, we also looked at our lake spy data, which is our submerged plant indicators. And that's a sort of method of characterizing the aquatic plant community based on how many invasive species are there and how many native species are there. So for Lake Waikari, invasive weeds were absent, but the native condition was actually quite low. And they're thinking this is because of turbidity. So there's a lot of sediment, which means the light isn't reaching the lake floor, and therefore the plants aren't growing as low or sort of around the sides. And more interestingly for Lake Waikari was that the turbidity was so high when they were doing the diving that they couldn't do their traditional methods for doing this data collection. So they had to change it because they just couldn't see any plants at all. Another lake we did, Lake Spy for, was Lake Mangawhio, and the lake spy data showed that there was a moderate level of invasive weeds, but there was low native plant conditions. So just like Lake Waikari, it was largely due to turbidity and unstable sediment, which really just limited plant growth. So overall, the lakes are showing us how important it is to manage erosion at the source, and that we can't restore what we don't understand. So without the reference conditions that we were hoping to get, the prevention of sediment problems becomes a lot more critical for these areas. And finally, I'll just do a brief covering of our estuaries. So the estuaries are super important because they lie at the bottom of the catchment. So they are getting the cumulative effects from all the freshwater upstream from source to sea. So the Waitotara estuary is the largest estuary in the region. It has a long tidal reach and a lot of intertidal habitat, and it makes it really dynamic environment. And the natural variation is part of why it's so unique, and so much so that we can't assume that it's in a healthy state just because it is dynamic or looks busy and productive, because it is still facing the same pressures as our rivers. And obviously one of the biggest ones is sediment. So as we know, the catchment naturally produces a lot of fine sediment, especially during high flows when a lot of that mud is getting flushed down river into the sea. And so in a place like Waitotara estuary, mud is expected and it is natural, but even natural sediment in high amounts can change how the system is functioning, which is why good land management still matters upstream, because it's all going somewhere essentially. So the mud content in our estuaries gives us a measure of how much fine material is actually building up on the estuary floor. While a bit of mud is normal, too much starts to smother it, and it makes it tough for sensitive species to survive. So basically, low mud levels means more diverse, more healthy animals. High mud means the opposite. And it's especially important there because of all the inverts that are living in the mud. When they go and when they aren't there, like, they form the base of the food chain. So if they're not there, the fish and the birds are sort of being affected as well. So it's affecting a lot more than just the system we're measuring. In addition to that, mud is sort of more like a sponge for contaminants, so it can trap things and hold heavy metals and nutrients for quite a while. So if we look at the results that are on the screen, we are seeing very low levels of metal contamination right now, which is good, but it's something that can build up over time, which is why we need to do long-term monitoring. And that's also why it's important that we are looking at the full picture. So on top of mud content, we're also measuring those contaminants, and we're looking at that fauna, so the stuff that's living in the sediments, because that's helping us catch signs of stress. And so, yeah, so far the results are showing that the mud content is a little bit high, but there is low metals. But what we don't know yet is how much of that is natural and how much of it is worsened by land use. So a big part of that is why ongoing monitoring is important, because as sediment pressures continue and climate change might bring more rainfall events, that sort of information becomes more important. So to summarise that, while the estuary is naturally muddy, we do just need to keep a close eye on what might be tipping that balance, and that's why it's important we're doing a whole range of monitoring across the catchment to try and figure out those changes and to why they might be happening. So just to summarise everything I've just said, in catchments like Waitotara, we know that there's a lot of natural sediment moving through the system, but that doesn't mean we can ignore it. So good land management is still really important to limit erosion and stop that extra sediment and runoff getting into our lakes and estuaries. And that's also why understanding why natural versus excess is so important, because it helps us set those targets and goals for us to work towards. So at the moment, for our macroinvertebrate and lake sites, we are currently drafting targets for target states for those sites. And within those two programs, at least, sediment is showing up again and again as a key driver affecting ecological health, but how it shows up might just look a little bit different depending on each site, which is why that catchment and site context becomes so important. But essentially these targets will help us guide our team into how we are prioritising the work and how we're prioritising management across the region. So ongoing monitoring is critical for this. So the longer the data set we build, the better we can pick up on those trends and changes and sort of differentiate whether it's a proper change or whether it's just short-term noise. So we're also, on top of that, reviewing our monitoring network to make sure we're capturing the right areas, especially in a case like the Waitotara when sediment is causing a pressure. And as part of that, one of the things that we would really welcome is including Mātauranga Māori more into the work. We want to be able to support whānau hapu and iwi-led projects to make sure we are incorporating those cultural values and when we are thinking about catchment health, because it's just as important. And yeah, so I guess following that, if there are any viewers who have any recommendations and would like to provide feedback, then please get in touch and we can start having those conversations, and we would really welcome them. But yeah, finally, while monitoring gives us the valuable on-the-ground data of what's happening at the time, it can't really tell the whole story on its own. So that's why we are looking at using tools like catchment modelling to help us build a fuller understanding of how the sediment is moving and impacts across the landscape. So following that, I will pass the screen on to Romy, our land and soil scientist, who will sort of cover that in her presentation.
Kia ora, I'm Romy. As Fern said, I'm the land and soil scientist here at Taranaki Regional Council. So I'm going to talk about the sediment modelling that we've commissioned through NIWA. So to start off with, we'll go back to the NPSFM, so that's National Policy Statement for Freshwater Management. So it sets out national bottom lines for visual clarity of rivers, which are those bands and grades that Fern was talking about before. So we have those for visual clarity in our rivers as well. So it's designed to set out a minimum standard for ecological health, so where fish and bugs can be supported, and we measure this using a black disc method. So it's a black disc in the water and there's a viewer, you move away from it and you measure how far you can see in the river as an indication of how much sediment is being carried through that river. So different rivers will have different thresholds, so as Fern said as well, with those soft bottom rivers, you're going to have a higher sediment load, so you're not going to be able to see as far just under natural conditions. So it's really important that we classify the different rivers to give them proper grades. And one of the things that we do is, or have done, is we've modelled suspended sediment as an indication of visual clarity. So the sediment model that has been used was the Sydney NZ sediment budget model. So sediment is really hard to predict and measure because it's literally coming from all angles and you can't easily get point source or diffuse source measures of sediment that's coming off land. So the model is fed by a bunch of different factors, such as like dominant erosion processes for different soil types, the slope, obviously the soil type, vegetation cover, and climate models. And the models estimate how much of the sediment is eroded in each of the subcatchments, and then those are all added together to figure out how much sediment will be coming through a river system. And one of the a second part of the modelling that was done as well was we modelled future changes under 4 different climate change scenarios, and part of that included the completion of farm plans. So the mitigation strategies that we do have, and that John will talk about a little bit later, and like full completion of those, what that would look like in terms of our sediment loads through rivers. And part of the modelling helps to identify where we are having sediment issues and where they're coming from. So the kind of broad scale conclusions of the modelling was that assuming the completion of those whole farm plans I just mentioned, up to 40% reduction in regional sediment loads is possible, not considering the effects of climate change. So that is things that people can do on the ground. If they're all completely implemented, then we can have a 40% reduction in sediment load region-wide. However, even with the full mitigation up and completely running and established and successful, sediment loads may not actually reduce significantly because we are combating the increased effects of climate change, which could increase up to 37% by mid-century. I just want to point out that 37% number is from the most extreme climate change scenario that was run through this model. So that's the RCP8, if anyone, or 8.5 if anyone's interested. And this is because in the future climate models, we'll have stronger storms, so we'll have more landslides, we're going to have bigger floods, so we're going to have more erosion coming from the sides of rivers, which is going to increase the sediment that we have in our rivers. So essentially, to remain at a state of equilibrium or to increase a bit, we are going to have to be completing quite a lot of mitigation actions. And so for the Waitotara catchment, we don't currently have any visual clarity measurements to truth the model, which means that we haven't got any targets set for the Waitotara catchment. But we do for the Whenua-Kura, which is a very similar catchment in terms of characteristics, slightly smaller, but in terms of like the cover of forest to, or natural to non-natural cover, they are pretty similar in proportion, very similar like soil types, and similar like soft bottom streams. And for these catchments, the national bottom line under the NPSFM will be difficult to achieve even with mitigation because of the natural state of these rivers and the contribution from natural cover, so forests. And what we do know about the Waitotara is that the dominant soil types are sandy and silty loams. They're really prone to erosion because they lack cohesion, so they don't really stick together very well. They have poor aggregation and structure, and there's low organic matter and shear strength, which are all things that kind of work well together in soils to keep them on the slopes, and without kind of adding in like your mitigation strategies. So the silty loam will have a slow infiltration, and then if you have kind of water flowing over that, you'll just pick it all up and run it down the slope. And then with the sandy loam, it has quite fast infiltration, so it'll flow into the soil, and then as it moves down, it could just like create a little gully or a rill that takes all of that sediment down into the river with it. And this is very similar for the Whenua-Kura catchment, which does sit in the D band for our visual clarity measurements. And this kind of brings in the importance of mitigating sediment erosion from all of the non-natural sources that we do have, because it's so easy for it to be mobilized if it's not managed. So these are the results of the two, the Whenua-Kura and the Waitotara catchments from the SEDNet model. And the numbers aren't super important, but the thing that I wanted to point out here was the proportions are really similar, and they also suggest that there will be increasing loads from contemporary, which is currently, so we've got our natural and our non-natural loads coming from the SEDNet model, and we've also got our future loads from natural and non-natural. And from now to future, all of those are saying that they will increase. And also just to point out that they're really similar proportions between the natural area and the non-natural area on that like kind of left side there. So we can make some comparisons between the catchments, even though we don't have these figures or the monitoring in the Waitotara catchment yet. And yeah, similar proportions but different scales. So Whenokura is a little bit smaller. So basically, to summarize all of that, there is high erosion risk from landslides and gully erosions in the Waitotara and Whenokura catchment. We can have some major improvements with the implementation of mitigation strategies. Climate change and also the high inputs from natural cover areas will challenge achieving the national bottom line. The sediment loads are calculated by a sediment model, but we do need to have a visual clarity site in the Waitotara catchment to truth the model. And once we do that and have some like continuous data, we will be able to set targets for this catchment as well. And we also need to continue our mitigation efforts and, like I say, improve monitoring in Waitotara. And Donna's going to talk to you about the mitigation strategies. So I'll pass it on to him. There's some links as well about what Fern and I have talked about. And there you go, Don.
Thank you, Romy. Hello, my name is Don Shearman. I'm the Land Services Manager. And I've been at Taranaki Regional Council for 28 years. One of my key responsibilities is to implement our Sustainable Land Management Program, which includes addressing the issue of accelerated erosion and the resulting sediment that you've just been hearing about. But also note, this is a statutory responsibility for TRC under the Resource Management Act and the Soil Conservation and Rivers Control Act. So keeping that in mind. Next slide, please. So this is just a generalized map of the region. It shows where most of the sediment originates from, and in particular, if you focus on the red areas, which is showing the source coming from generally landslides, but also includes earth flows, which is going to most likely end up in a waterway. It's pretty easy to see there that there's not much red showing up in this model under a forest cover, although as you've heard before, there is a natural component, but compared to pasture, a different story. So next slide, please. So here are just some stats on the hill country. I'm talking about all of the region at the moment, but this is actually a photo in the Waitotara. But it makes up the largest portion of the region and has over 40,000 hectares that's highly erodible and most likely to provide sediment to waterways. And that's obviously the part we're interested in this webinar. But also note that roughly around every 5 to 7 years, somewhere in the region, we have a significant storm. So it's not always just in the Waitotara, but you can see there by those dates at the bottom that Waitotara has had a series of storms over the years, not just in the last person's commentary on TV that they don't remember a storm in their lifetime. That's usually only 30 to 50 years. Next slide, please. So how does TRC go about dealing with this issue of accelerated erosion and sediment delivery to water? So we basically work with individual farmers to prepare farm environmental plans. They provide the sustainable land management recommendations for soil conservation. So 82% of the land in private ownership in the region is covered by our program, and that's increasing every year as we prepare new plans along the way. The white colour, well, it's grey-white colour, shows the plan coverage, and the yellowy colour, the actual plan holders also that are participating in our soil conservation grant scheme, which I'll go into a bit later on. Next slide, please. So the key component of a farm environmental plan is the land use capability mapping that we undertake. So this is a detailed field analysis of the physical factors that make up the different landforms on the property. We use this information then to classify the landforms in order so that we can understand their physical strengths and their weaknesses. As you know, not all rock types are the same, and they can have very different erosion vulnerabilities depending on what the grains are made up of, clay, silt, or sand, and how well they're compressed together. And, you know, this has a major determination of these different erosion properties. So the recommendations are then based on the information that we get from the LUC mapping, and then those recommendations go and refine an environmental plan. Next slide, please. So this is what the actual map with the recommendations on it looks like in the actual plan. You can see here a mixture of afforestation, retirement, reversion, space pole planting, and fencing off of gullies, etc. So all this work is created and stored within our GIS system so that we can analyze it and do our reporting for the year. Next slide, please. So the focus of the seminar is on sediment. So it's important to know which geologies are vulnerable to which erosion types and where they're actually located. Most importantly, what the most appropriate treatment is. You can see here this bottom left corner here. This is not a soil slip, and these are also very common up there. They are earth flows, semi-slump conditions that are being undercut at the bottom by a waterway, which basically just keeps feeding in another lot of sediment until that's been treated. So you can see there on the right, for these sort of, you know, to treat these sort of erosion types, you need a deep-rooted species with an extensive interlocking root system to halt and slow this earth flow down. So fast-growing deciduous poplars and willows are ideal for this. Next slide, please. And this slide shows why, because this is what the underground root system of a 3-year-old poplar looks like. That's quite significant if you're comparing it to some of the other, you know, the native species. So when planted at the correct spacing, each tree will interlink with its neighbour, forming this interconnected network like the reinforcing of concrete, and that's the system you need to slow those massive earth flows down. But if you've got native biodiversity of the goal, there's no reason why you can't plant something like Kānuku or Manuka once it's stabilised, you know, within a few years' time. Next slide, please. So I said I'd come back to our grant scheme for soil conservation. So this is what we call STRESS. It's an acronym for the South Taranaki and Regional Erosion Support Scheme. Basically, we distribute government funding to our plan holders in the form of grants to help reduce the cost of implementing the soil conservation measures. We have around 900,000 a year for the next 2 years, and then we'll have to reapply again to the government. You can see the different treatments there in the first column and the totals outputs for each treatment since we've been in the scheme since 2009. I mean, they're quite significant outputs when you look at the totals of treatments, but the key question is are they making a difference? Next slide, please. So let us look at the program and the actual Waitotara itself. You can see the white and the yellow colouring of that plan coverage, and just note all the green in the North Soil Conservation Estate, native bush. That we're working with basically most of the farmers in the catchment, and our plans cover 90% of the pasture, which is, you know, roughly 18.5 thousand hectares of at-risk land of the most targeted area, steep land and pasture. So most of the plan holders, they're implementing the recommendations, albeit at a pace they can afford, and that's always a key factor. After all, our program's still voluntary and there are no regulations forcing farmers to do anything. So all this work is achieved through our relationships with our farmers and plan holders and convincing them, you know, these are the right things to do. Next slide, please. So lucky last. So in summary, if you look at the three maps and the yellow areas showing up, the map on the left is they represent the areas where the sediments most likely to be coming from. And that represents the state before our program of working with farms and doing anything. The middle one represents the current state of what we've achieved to date. And the one on the right is basically the future scenario where we could be making further gains, and a lot of that will depend on, you know, the outcomes of climate change, etc. But you can see the area of yellow there representing the problem areas is diminishing. And this is based out of this SEDNet model that Romy's just been talking about. And if you want to see the actual absolute, you know, tons per year, they're up in that table in the corner, and no doubt this will be on the reference for the website and to find out further information. But as you've heard before, the predictions by the model are based on the assumption that all plan holders are implementing all the recommendations in their plans and that they're all old enough to be functioning, you know, the plants are growing enough to be functioning and doing their job. But the reality is that every plan holder is at a different stage of implementation. And, you know, but all the treatments that have been implemented in the past and that, you know, plan holders are doing now, I mean, it is still making a difference, obviously, but lining up with the model in a perfect situation is, you know, another story. So it's our role to facilitate the implementation in the shortest time, is obviously desirable, but the shortest time practicable to get this work implemented and functionally to hold the soil together and obviously reduce sediment. So we are actively doing that, and we'll continue to work alongside farmers to get more and more work implemented. So any information and detail about any of the presentation, just contact Regional Council, and you know, if you want access to getting a plan or any of the grant funding, just get hold of the Regional Council. So that's all from me. Thank you.
Ngā mihi nui kia koutou. Thank you so much for taking the time today to share insights into your work and into, as we've talked about, the state of affairs in terms of sediment from the monitoring side, but also in terms of the future modelling. So, Don, you mentioned in terms of if anyone would like to have further conversations to get in touch with you, and that will also be on the website, so the contact will be accessible there. But also if someone's interested in kind of more details in terms of the monitoring data and the modelling results, how would they kind of, would they just get in touch again with you about that, or how's that accessible?
Yeah, I can answer that. So you can either, if there's anything specific, you can either get in touch with us through our details, or in terms of the monitoring, if there is specific data or specific results, if they're not on our website, then you can put an official data request on our TRC website, and what that does is it gets filtered through to us, and we can get the data, whatever data in question, to you in any way you would like. But if it's just general conversations or wanting something specific, then yeah, you can get in touch with us directly.
Right, thank you. And I just had kind of a follow-up question, maybe. I mean, there's probably very many questions, but that would be a whole lot of other conversations. Was that you mentioned in your presentation briefly in terms of the partnership with mana whenua and how there can be partners and also in the monitoring as well as the modelling. So is that sort of on the way, or what does that look like in terms of that collaboration?
Yeah, I mean, we encourage it all the time. We would love to have those conversations more and more. So if there is any groups that do want to reach out as well, reach out to me on my details there, then we can go from there and start those conversations. But I'd love to have them.
Great. Yeah, thank you. It's good to kind of to let people know that if they do want to reach out, that the door is open to do that. So yeah, again, thank you so much for today. Really appreciate it, and we will talk soon. So I'll kind of wrap us up here. And
I just
did you have
wanted
something?
to-
Yes.
Yeah, I just
Yeah,
wanted to correct something. I believe I said earlier that it was a Niwa model, but it's actually a Manaki Whenua model. I was just looking at a different one this morning. I think I got confused. But
Cool.
just to clarify that.
Yeah, thank you. Thanks for letting us know. All right, so thank you so much, everyone, and I'll wrap up here. So, ka kite anō.
Thank you.